Hi, good morning. I guess it's almost done, so let's see the discussion. So it seems like it's more like spread out. So I guess I need to discuss a little bit, or it might be due to the difficulty level of the question. So let's go ahead and discuss a bit about the question before we break. So let's quickly go over the questions. So can you see my, so see the questions? So let's go over one by one. And then, as we see, basically they're applying the formula directly, okay? So here, the first question, sorry for the noise, I guess there's someone in office are drilling. I hope that is okay. So the first question here is the average salary of airline, okay? I guess this is somewhat related to Cathay Pacific, right? I just changed the number. Standard deviation, so just a pure guess, it's not fitting any data. So a sample of 100 employee taken, and what the standard error of the mean, right? Standard error of the mean, right? It's just this, right? Basically, the standard deviation of X bar, okay? So that is 1.2 million, right? Over root of 100, right? So it's 0.12 million. So the answer is B. Is that okay? Yep. I hope that's okay. So the next question is asking you to do the central limit theorem, okay? So X bar not central limit, but basically the central limit theorem. So X bar is 60 and sigma is 3, okay? So already give you already normal, more or less, right? And n is 36, right? So then probability that this 61, so basically this is z is greater than 61 over 60 over 3 over 36, right? Because the standard error, right, is 3 over 36, right? It's 1/2. Okay, so the probability that z is bigger than 2, right? Then how you do that, right, will be 1 minus ln s this 2. Is that okay for this one? Good. Here have a normal disputed with mean this and this. Okay. So basically x has following normal 2.1 square, right? And asking this 1.99 x bar 2.01, the same idea again, will be z, okay? 2.01 minus 2 over 0.1 over root 12. 1.99 minus 2 over 0.1, okay? Then you can see, you can calculate the number, okay? And again, put in Excel, right? So this guy, right, will be norm S this, right? 0.3461. The same here, but negative. Okay. So that would be the way to calculate. Is that okay for this question? Any question? No. Then the next one, this is sample proportion question. So in a certain school, 40% are afraid of dogs. Okay. And 20% are taken. Okay. So basically pi is 0.4. Okay. So and n is 20, right? So basically the p sample proportion, right? So you can check actually this apply, right? Because n times p is 20 times a, right? 0.8. Sorry, 20 times 0.4. So it's 8 is greater than 5. N times 1 minus p is 20 times 0.6 is 12, is also bigger than 5. So you can apply the formula here. N will be normal 0.4. This normal because this apply, okay? So 0.4, and then it will be would be 0.6 times 0.4 over 20. Okay, so then you can see, you can calculate this, right? It's give you 1.05, right? So the question is asking what is the sample proportion? P is between 0.39 and 0.41, right? But you know it's normal. Just apply it directly, right? Probability that Z will be given by 0.41 minus 0.1, right? It's 0.01 over, this is 0.1095, negative 0.01, 0.1095. Okay. Then give you these two numbers. Okay. Again, use the normal inverse. You can calculate these two numbers. Is that okay? Is that okay? Any question? Yeah, proportion. Yeah. I guess in the question I forget to put the percentage, but sample proportion is asking the percentage, right? It's a fraction. It's a mean of the population where involve only 0 and 1. Is that okay, Junso? How to do that is norm as in, not in Word. This is the PDF, so we just norm. So we'll be just norm as this. Whole in is okay. It's not in Word. In Word, so this is normal, right? You are trying to find for this number to go to here is norm as this. Okay. If you from this area to here, you are doing the norm as inward. Okay. So you do the norm inward usually when you do the hypothesis testing, right? That's actually what we're doing, right? It's like try to find the Z alpha, that is use the norm as inward. Okay. Any more question? No, then we continue. So an economist, probably me, right? So the monthly income The standard deviation is known as 1,000, right? And 50 individual result in median income of 50,000. Okay, it's close to Hong Kong, I guess. The margin of error, 20%, right? That would be margin of error, ME, right? Would be Z, yeah, alpha over 2, and because we know this, we can use the C score because we know this, right? Because sigma is 1,000, okay? So that's why we can use the Z. Yeah. And it's 1,000 over root n is 50, okay? And what is the Z here, right? Here alpha is 10%, so it's 0.05, right? Z is 95, okay? The reason, 0.05, okay? The reason is like this, right? Because 90% times 90%, okay? So the both sides are 5%. Okay, so this is, right, the probability that Z standard normal is less than 0.97, sorry, Z less than, that's Z, we are trying to find the C, is equal to 0.975, sorry, 95, because from here to here is 95%, okay? So just direct calculation, right? So this, do the calculation, right? So this guy, okay, is 14.42, and this is 1.645, and you multiply them, will give you this number. Is that okay? So if you have hundreds of sample, then your sample mean, the width interval will be 200 something. So that's pretty accurate. Okay. So here an economist is interested in studying monthly income. So it's the width, okay? The same question, but the width will be 2 times of this margin of error, right? The width. So that's why it's multiply what we have found in the previous question. So it's just 46, 460 and 5. Is that okay? Okay, good. So question 7, oh, I guess I make a mistake here. So this should be the margin. Sorry, I guess the reason why many of you are unable to get it right, the margin. Sorry. I will change I will cancel this question. But how do we do this question? Here, n is A, right? X bar is 180. Standard deviation is 140. Okay. And what is the margin, right? Margin of error. Should be margin of error, not the width. So here you can see we have T n minus 1 alpha over 2 S over root n. So n is 8. Okay. So here you look at 7. Okay. 95%. So it should be, let's look at the Excel. So we have sample of A, 95% confidence. So here is, so sample size A, okay? So N is A, and we will have alpha confidence, I think 90%, right? So what is T n minus 1 and alpha over 2? So alpha is 10%, is 5%, right? 95, I think it's 95, right? 95. So 10 is 0.25, 0.025. Okay. So then how do we handle this? Will be T distribution. Okay. And because we want the other way around, so T distribution is T inverse. And probability is 0.975. Okay. And degree of freedom will be 7 with n minus 1. So the formula like this, okay? Because 95%, so it's 2.3646, okay? So I guess this is fine. I think I write down the answer wrong. It should be 0.025, okay? But the answer is correct, just the formula is wrong, but everything's right. So you multiply this, again, the standard error, they give you 117. So this is a typo in the question. I guess I should change it somehow later. But that would be how you calculate D. Is there a question? So is there a question? If no, then we continue. So here I want confidence interval for the proportion, right? So here I have n is 300, right? And x 330, right? So the sample proportion will be 0.1, right? Because this over that. And I want the confidence interval, right? So there will be P plus minus Z alpha over 2, okay? Because NP is 30, right? So it's bigger than 5, and NP, N1 minus P is 270, so bigger than 5, so you can use this formula. So then we have P times 1 minus P over N, and then take square root, right? So that would be, this is 0.1, this is 0.9, this is 300, okay? And take the square root, give you this number, okay? And we have Z alpha over 2, which is 1.46 because 95%, so 1.64, okay? And because then you calculate this guy, okay? And according to this formula is 0.028, okay? And P is 0.1, okay? So 0.1 plus minus 0.028, so it will be B. Is that okay? So real quickly, the last two questions, I guess. How large the sample we need, right? N is Z alpha over 2 square sigma square over ME square, right? So, so 150 times 95%, this is 1.96, right? If you forget how to do it, this is 0.025, right? Would be 1 minus would be coming from norm as inward 0.975, okay? Square over the margin error is 50, okay? So exactly this formula, okay? So that is, so at the end you need 47.5, so you need 35, okay? So the very last question, here we have sample population proportion believed with this guy, okay? So pi is this guy, and so someone asked me question A. Question A, pi is 0.1 because sample 30 are defective. It's a proportion. So we want a 95 confidence level for margin error like this, right? So the formula would be n is equal to z alpha 2 square p pi times 1 minus pi me square, right? So basically it's 1.96 square, 0.4, 0.6 over the me, which is 0.03 square. Okay, so you get this number. So that's why you get the round up, you get this answer. Okay, let's have a break of 5 minutes. I guess we have a little bit tight schedule today. So let's have 5-minute break. So we will resume at 9:43. I'm sorry. So I short a break because we spent more time on the quiz. So the several question. So during the break, someone asked me the two things. So someone want me to explain the question 8 and question 4 again. So let me go to question 8 again first, and then go to question 4. So here is a proportion, right? So 30 of them are defective. So how many of them are? So we 30 over 300. So that's why 0.1. Because the data is either x is equal to 0 or 1, right? And the mean will be 30 over summing all of them over number of them. Is that okay, DSME? Another question is asking me to redo the question 4. So I guess probably I didn't make the portion, forgot the percentage, but here 40% are paradox. So basically what we're saying is this pi or p is 0.4. So sample proportion is a proportion, right? So n is 20. And because 20 of them, so asking what's probability that the sample proportion, which is p, is between 0.39, sorry, it's 0.41 and 0.39, right? And we know p can be approximated by normal because n pi and n pi and n1 minus pi are bigger than 5, okay? So that's why we can use this idea of Okay, so this is normal approximation here. And that's why we can write z, right? 0.41 minus 0.4 over square root of this guy, right? So it's 0.4, 0.6 over 20, 0.39 minus 0.4 over, sorry, 0.4, 0.6 over 20. And then you can, the rest follows. Is that okay? Is it okay for this one? Chuckman, Junkman. I don't know whether I pronounce your name correctly. Is it okay for Q4? Yeah, no, it's in Word because we are using this, we're calculating this probability, right? We are finding probability is always the distribution. In Word is from the probability, go back to the, what is it, Z. The reason here is we are asking this number, right? So we are giving this guy, right? It's 0.9128 and negative 0.9128. We want to find this probability. So this is probability of the Z space, right? So to find this area, right, we know that the normal, right, to find the left hand side area, right, is f of z, right, is given by the norm as this. Is that okay? Yeah, I can. So other question is, can I repeat the question 7 again? Before that, Jasmine asked me the point 1 is the question 8 is asking, this is sample proportion. Yeah, okay. Right, I mean, should be more, is more like the P, yeah. Yeah, X is 30 and the N is 300, right? P will be 300. No, in this question, we don't know pi, yeah. And another question, you're asking me to explain question 7 again. I guess the question is because should be margin error. I think a typo over there, should not be the. So the question is asking the margin error for the mean where we don't know the we don't know sigma. Okay, we have no sigma. Okay, so we need to use t n minus 1 alpha over 2 s over root n. Okay, and we shown in the Excel. This part is 2.364 and s is 140 and root n is 8. Is that okay? I mean, Hoi, is it okay? Oh, we remember here we want to find what the t that satisfies this, right? So we want 95%, okay? That what the t of this guy is, right? From probability go back. So it should be t inward. If you are, because you are not coming from probability back, is inversion, okay? Because what the formula is usually, this is the formula, right? T, the probability that t is less than or equal to t. So this probability is the function that is called, that is the distribution, right? With t dist. It's called distribution function. So we want to go back, right? It's the inverse of this function. So f inverse. Is that okay? Is it clear what? NP MPI. So what's the question is MP, MPI? I mean, you mean NP and M1 minus P? Is it? Hoi? Maybe you can talk because I'm not sure I understand your question. NP equal to grid. Where you found this question? Sorry, I didn't.
I want to ask what's the differences between NP and MPI. I saw you in some question you
Oh,
are
I see,
using
I see.
NP, and in some
So
question you are
pi
talking
is
about
equal,
MPI.
oh, okay, I see. Pi is the population proportion. P is the sample proportion. Just the same as, okay, this is just mu and this is X bar.
Okay, I get it. Thank you.
Just notation. I mean, you can use the same, doesn't really matter. Any more question? If no, then any more question? So I hope that would let you work a little bit. But don't worry, we will have assignment 3 after you submit assignment 2 that you will train yourself to do more of this type of question. I guess I hope that would be. So someone asked me again the question for. You didn't get the. You want to show the Excel or what? Is it? Are you okay up to here? So let's see. It's so 0.912A. Let's see if I get it right. So the question is 0.912A. It's negative 0.912A. And I want the norm as this because I want to find the probability, right? True. And take a difference. So this is how we get. Maybe I just copy the formula so that you can see. Is that okay? Chukman? Is that okay? Is that okay? So this is how you get this number. So this is the formula and take the difference. You can try, and then if you still question, then ask me. I guess without further ado, then we should continue our journey on hypothesis testing. Suppose we should able to finish the 1 sample test, and then we'll do the 2 sample next class. So before we start, there's several things that I want to announce. I guess probably many of you might know because a majority of you prefer the online class and same as all the 2,000 and 3,000 classes in B school. So I guess you might know that for my class and also probably for all other 2,000 and 3,000 classes, the rest of semester will be being online. Okay, so in that case, any question? Okay, we will be so everything will be on schedule, I guess now. So more or less on schedule. So that's why we will be following the schedule that we will do the exam on the 26th. Okay, I think we'll do it at night. So I will probably send out the put the announcement in the black box, and then we will figure out what to do, because to make sure that everything is the same quiz. So that's why if you know you have official reason to miss it, let me know. We have to figure out how to make that up first. But otherwise, we all have the quiz on the at the night of 26. The group project, I would be doing that. I will be putting the detailed instruction there. So you'll be asked to do the when's test? Okay, the test will be a 26, same as what I think will be November 26 at night. Sorry. Yes, it's November. Yeah. Open book. So that's why I want you to put it at night, so that yes. I guess 26, right? I think I write it in the syllabus is 26, but let probably put there, because at night, because I want to make sure that those who are not in the same time zone can have the more fair one. But I made the announcement on the thing first, and then let's see if there's someone who are unable to attend due to the time zone difference, and I'll try to figure out the tentative time is at night, so maybe 7 to 9, I guess, the standard one. But let's see what happens, what we can do on that one. But that would be a tentative plan, because everything is online. So we will be at the test. You have to open your Zoom video. Okay, so I have to proctor the exam. We will open book. Okay. Any question on that? Is that okay? I put an announcement there for the project and also the quiz. I guess we have figured out how to do the online one, but it will be an online version. Yes. I think it will be 7 to 9. Would there be any particular issue on that? I'll make an announcement for the on the Blackboard. Maybe I send an email to you. That would be. I'll do both. I guess that would be important enough to do both. Because online, so for the project, I guess the presentation have to be online too. So because of this time zone problem, so I guess the two choices for you. You might record your video if needed, or you can, if the time zone difference. Otherwise, you'll be better to have a real-time presentation. You do the Zoom. You can host it. Otherwise, if you have the time zone problem, then you can submit your recorded video. Oh, for the exam, I think we will give you the check answer during the test. I think we'll be follow standard traditional way of exam. I think you put I guess it's like, I think you will do paper based. I guess you write on your paper and you take a photograph. I think that would be easier, because I want to show the thing. So I think to put the question in PDF, I think that would be easier, right? I guess I'll put the thing and then you can ask. I guess I try to put the structure there. I guess I come up with the thing. Probably we'll talk about more on Thursday, but that would be, yeah. Thanks for asking. But that would be the goal. I guess the way classical way. I put a PDF file over there and you can just do. Okay. Mock paper. I guess it will be somewhat similar to other sections, so it's not something should not be something surprising. So I think you can check the mock paper of others from other sections from the history of the past, so they'll be similar. I think I mentioned that. Any more question? But of course, you have to do so many quiz and also the assignment. I guess that I think the question would not be. I think the question would be in line with assignment or the quiz. Of course, maybe a little bit more difficult, but or even the same difficulty, maybe we have more question, so that I can distinguish who will get A, who will get A minus, and so on and so forth. But otherwise, should not be very difficult. Okay. I think the difficulty will be similar to other sections in the past or concurrently. Okay, any more questions? Okay, if no, then we can start. I mean, feel free to ask. I think would be the just scan or type or right. Okay. So let's get started. Hypothesis testing. So let's review what we have done. Okay. So with the one sample style, so the idea is the main idea we do is we say someone say the sample mean is certain number. Okay. We're trying to see if this is supported or not, right? And then we will consider what is a evidence that is not supporting the null hypothesis, right? So we have to say whether it's one side or two-sided. If both sides are violated, then if both sides, oh, sorry. So hypothesis testing. So just a null hypothesis or the alternative hypothesis, okay? And just to remember that is the idea is you decide what is the null, which usually given from the question, and alternative is you would decide what would constitute a evidence that you would want to reject, right? So that's why you will see whether you're two-sided or one-sided, right-hand side or left-hand side. Right-hand side means if what you see is way more than the sample, way you see more than the A proposed hypothesized mean, then you will reject, right? Because you know by central limit theorem, right? The sample mean, right, will follow, if this is right, right? A will be here, right? And using the z-test, actually, we know the sigma again, right? So we know if the data you found is actually here, okay, we will say this is far away enough, then you would be favoring H1, right? Then how far you say is far away, so we will say this is, we say this alpha is the threshold, right? So if this is smaller than alpha, then you will reject, right? And the alpha you want to put is 5%, as usual, or 1%, or sometimes you want 10%, but the most standard one is 5%. This historically people use 5% from a statistician, Fisher. He said 5% is convenient. I mean, there's no point, no reason why it's put 5, why not 6 or 5.5, but historically people put 5, and this is the standard way we do the idea. Okay, so what you do is you collect data and you do this X bar, right? And then you convert into the Z world, right? Z world, right? Mean 0 and variance 1, right? And you can see whether X bar is bigger than the Z alpha, right? Or this area is less than, the P is less than alpha, okay? Then you can reject. Okay, so this is what we covered last time. So let's go over it again, the example, okay? So to begin, so we know this sigma is 4 and n is 64, and sample mean is 5. Okay. Now we are saying that we are rejecting on the right. Okay. This is the given from the question. Okay. So from now, this is the part we are trying to do. Okay. And here is to test this is use a z-test because we know the population variance. Okay. So that is, we want x bar minus mu over this. Why this? Because this is follow a normal CO1. Okay. And we are saying that if this is far more than 4, then we are favoring H1 more than H now. Okay. And this turned out to be 2. And if you draw it, right, from the Z, this is 0, this is 2. Okay. And we know it, right? This area, if this area is 5%, okay, we know this is 1.96, sorry, 1.64, okay? And that means this area on the right hand side of 2 is far fewer than 5, okay? So that's why you will reject at a 5% significance level, okay? So of course, how do you come up with that? Because this is usually 5, so we just use 5. If we didn't say it, then you use 5. Okay. And an alternative, you can calculate the value of this area, right? It's called the p-value. So calculate that, give you this, how you calculate this guy. Okay. This is 1 minus norm as this 2. Okay. Because we want to find probability. Is that okay for this part? Any question? Okay, good. So let's do the other example that we have seen so far. I think we just rather click on this one. So the same idea here is, again, the question is given like this, right? We have sigma is 4, n is 64, x bar is 3, h now, we say mean is 4, okay? And when we would consider that would be a violation of this is mu is less than 4, okay? So to remind you why we care about this, maybe we just care about less than, right? Say, suppose you want to, someone claim that the mean of maybe a package of the food have 4 kg, right? And then you try to see whether it's less than 4 kg, right? More than 4 kg is fine, right? It's not cheating, right? But if the product is less than 4, then probably it's a problem, okay? So we want to prove that. And the sum is 3, then is it going to be too far away from that, right? Then what you can see is, suppose this is 4, right? And right, if the mean, if this is actually 4, the sample mean will have expectation, or the mean of sample mean will be 4, right? With sigma over root n as is a standard deviation, or sigma square over n, right? If the variance, right? Variance of x bar, okay? And now we have 3 here. Then is it far away, far below from 4, right? How do you say below? Then you try to check this area, right? So that's why the standard thing is you try to convert this from x space, right? Because x bar will be normal with mean 4. If you assume this is true, okay, assume this is true, mean 4, and 16 over 64, okay? And you convert it to 0 here, okay? And what is 3 here will be -2, okay? And then you are trying to see, oh, is this area is small enough? Or on the other hand, you can look at the 5%. Okay? If this area is going to be 5%, okay? This area is -1.64, okay? and this is on the right hand side, right? So that's why less than that, then you reject, okay? Or I calculate area, which is the same idea, right? Use the norm as this, -2, okay? Give you this answer, okay? To calculate this, to remind you, calculate this, right? This on the other side, right? You want 5%, okay? Would be the norm as inward, okay? 95, okay? So that's how when one here you inward, here you this. Is that okay? Is there any question? No? So we will go to the next part. So that is exactly the same, but we just repeat. So the procedure is like this. We're saying that mu is equal to A and mu is not equal to A, okay? So that the idea is the following, right? X bar A here, we will say if you give me the evidence from the right hand side or left hand side, I would both would try to don't want to support the hypothesis, the null hypothesis. The reason may be sometime you want this equal to particular value. If it's not the case, then you would reject, right? For example, medicine, right? Medicine for the drugs, it's very important to have the the active ingredient to be exactly the amount of stated one, because more than that can kill people, less than that can be not effective. So you want exactly this same amount, right? So again, you do the same idea, you do the z, convert it a to 0, right? And you want to try to check whether, do you note that this is z alpha over 2, this is z alpha over 2, y alpha over 2, because this 1 minus alpha, right? So you want to be symmetric, so you want both sides alpha over 2. Okay, so this part is very similar to what you do the confidence interval estimator, right? Because you put the center 1 minus alpha, both sides alpha over 2. Okay, is that okay for this one? Maybe I can show you the example, then you will see. So this already set I have just done. So the little bit interesting part, the p-value have to be 2 times, so a little bit trickier than usual, but otherwise will be the same. But we'll talk about this in the example. Okay, so let's see this example. Okay, again, this is the question. Standard deviation is 4, and is 64, x bar is 3. Okay, so that means, again, let's repeat the question here. Okay, this is the given this is true. Okay, according to this is what we have. Okay, this sigma over small with n, right? This again 4 over 16 over 16 over 46, right? 1 over 4, right? So then you want to convert it to z, right? How do you convert, right? Would be 0, right? You just x bar minus 4 over 1/2, right? Because and what we calculate, figure out the data you have is sample mean is 3, so that's 3 here, and you convert this is -2. I think we have the same, do it again, so I think you should know how to do that part. Okay, so how do we say rejection, right? Because Now what we have is we want the center, we put the center as we want to figure out this is 1 minus alpha, right? And if this is 1 minus alpha, then we say sampling mistake is not too far away, right? The both sides will be alpha over 2, right? Maybe use another color. Okay, so we want to see what is this number, right? So go down a little bit here. Okay, what is this number, right? If this side is alpha 2 and this alpha 2, and then we pick alpha is 5%, right? So we pick z is alpha 2 is 1.96. I think for many of you would know how to do this. The formula would be norm standard this, right, 0.975. Okay, so give you this answer. And this give you is 1.96, and this negative 1.96. Okay, and that means this is further away from the fractal, so you reject at 5% significance level. Okay, or here is the more tricky part. Okay, do note that when the two-sided a little bit more tricky, the value will be 2 times of bigger than absolute value of this one, or smaller than absolute value of this one. Okay, so the reason why the two-sided, so the p-value have to be double, right? Because you separate from two sides. Okay, the p-value will be 2 times of this value. Okay, 2 times of this area. Okay, and this area same as this area too. Okay, so just remember how we get this is norm standard this 2 1 minus. Negative 2, not 2. So 2 negative 2 is oh, sorry. No, this is so this is inverse. So, yeah, sorry. Yeah, someone remind me this should be inward, because we are coming from the probability, go back to here, and 0.975. Yeah, this is right. Someone said 2 is bigger than 2 is bigger than 1.96, so that's why we I see. Sorry, it's a bit bigger than, yes. This is because you separate the area from two sides, so p value will be double, because we are comparing the alpha and the p. So because we always compare alpha, this is for the p value, and we compare p value to alpha, but actually you should compare p to alpha over 2. So that's why this is this. By default, p is double of the probability, that more extreme than that. So there's no particular reason, but this is a standard way people define it. I mean, I see this a little bit tricky, but that's how people define, because you can look at textbook, p-value is defined as probability that z is bigger than the absolute value of z, and 2 times. So there's no reason why you do this, but this is the case. And just to remind you that you don't need the 2 steps. So either you do 1 or you can do 2. Okay, you don't have to do both. Okay, just to remind you that you don't need to do both of them. Okay. Sorry, I run out of time, but maybe let me give me the 5 more minutes to finish a little bit. I want to talk about the T before, at least talk about this before we go. So you would see this part will be the same, except now we don't know the sigma square, we don't know that part. So we have to use S square. So everything the same, but you will be using T instead. So we'll be using the T. So we'll be T this, and we'll be T inward. Okay. So basically everything the same, but instead of using norm standard, we're using the T. Okay. So that would be everything will exactly the same. Okay. So let me give you one example. Then we will end today's class. So don't worry, that would be the same thing here. So the same question again, okay? Sample size 16, sample variance 2, sample sensitivity is 2, sample mean is 5, okay? We will, again, the question is sample mean is have the mean 4, right? And what we found is the sample mean is actually 5. So is this small enough? And this is no longer normal because we don't know the sample variance, but we don't know population variance. So we have to use this one. The reason is if we don't know this one, this guy, right? Probably we just to remember as this, have a t distribution of n minus 1. Someone asked me, is it, when we use t, we have to, when we don't know we don't know the population variance with t. Yeah, exactly. Okay, so this is exactly we need t here. Okay, so it's not going to be z, with t. Okay, so that's why t here, but there's no difference. This is again 0, this again 2. Okay, because I deliberately make it the same. Okay, so the same question here. But now we are not going to check this t table, check the c table. Okay, how do you get this one? Right, would be the t. So Excel will be t dot inward. Okay, you have to put the probability. Okay, because alpha is 5%, so you put 5% here, so 0.05 for Excel, and then you put n minus 1, n is 16, you put 5. Okay, because for Excel, it's just you put the probability, this is degree of freedom. Okay, and this is you put the value. Okay, so this is Excel, you put in this way. So it turned out to be the 5%. Let me use the color. So for this to be the 5%, this value is equal to 1.7. I think so. How to figure out this? This is coming from the Excel. You can just try it by yourself. This is the Excel. You need to put in the 95. Okay, because Excel is not using the left tail, so it will be 5% here. You put the tail, you have to put 95. So Excel, you have to put in this one. It's 95. Okay. As t inward, yeah. Why is inward? Because we've coming from probability convert to t, that is what the inward. Here is inward, inverse. This is the t distribution. So distribution function, I mean, many of you asked this again, distribution function is the cumulative distribution function, right? It's f x is probability that x is less than x. So give me this, I give the probability, okay? So give you this area, I find probability, that's a distribution function. We reword it, is we give you the probability, we want to get back the z. So it's reverse, it's inverse of that. So that's why it's IN is inward. Is that okay? Hoi. So this is the answer. 1.735. So this is our 2 is far bigger than this one. So that's why I reject this at the 5% sort of this level. And again, you can check what is the 2, it was the area of this, okay? I'll do that same idea. You would do T this of 2. Again, you take 1 minus because the fact that the answer gives you the left-hand side, so you want the right-hand side here, okay? So because this only gives you this area, T15, give you this area. You will take 1 subtract from that, okay? So I guess almost time for me today, but we're almost done for the 1 sample, so we are on time. So but we will be talking about 2 sample after talking about the right-hand side, left-hand side, and two-tail, but that is almost done for today. Okay, I think that's all for today. Just to remind you that for the rest of the semester, we do online, and the exam will be on the November 26th, and then we will do the project same as what we said in syllabus. But I will give you more information today or on Thursday. Okay, so see you. Thank you very much. Have a nice day. Bye-bye. I'll stay around to answer the question you might have. Please feel free to ask a question. Bye-bye, bye-bye. Thank you. So because it's a one-sided, right? You want all the probability because what is alpha is 5% here means that because 1 minus alpha is 95%, right? You want 95%, and you want 5% is the sample error, right? So that's why this is the 5%. You want to see, is it bigger than 5% or less than 5%, right? Because that's the terminology we are using is saying that, is it far away enough from 5, right? Is it is it bigger than 4, big enough, okay? We're saying big enough if this area is less than 5%. So that's the idea. So there's nothing but just definition. When it's one-sided, is it big enough? Is it smaller than 5%? Two-sided, we will equally divide it in both sides. So that's the idea. And why is it the case is convention. Why two-sided is half of the one-sided? Just convention. It's not just you just remember why this is the case, but one side, two-sided.
即係如果佢係two tails 嘅話，咁就要將佢除以。
係啦，因為你係兩邊都加埋即係中間係90，佢係講緊中間嗰個係95啊嘛。
哦，唔該
中間95，
曬。
咁你如果兩邊都 reject 嘅話，咪 divide by two 咯。如果得一邊嘅話，咪唔咯，即係佢講緊中間，佢係講緊95%係講緊中間95%。OK 嘛？
我可唔可以問下咧？佢 reject 個 part 咧係即係我計到個數係1.753啦，跟住係咪因為佢大個所以 reject，定係因為佢太多所以 reject 啊？
因為1.753即係5%啊嘛。
啊，
你睇唔睇到我個 screen 啊？
睇到。
咁佢即係話你點樣 reject 就係話呢個機會佢非常之細啊嘛，係嘛？首先第一個問題，你明唔明點解 reject 就係話你講話係4啊嘛？咁你大過4好多咁咪 reject 啦，係咪先？
係。
咁你咩叫大過4好多咧？咁即係話你揾出咗嚿嘢大過4好多，即係話呢個佢大過嗰個你揾出咗嚿嘢嗰個嘢係細過5%咧，咁你就算 reject 啦。咁你點樣做咧？一係你直接揾佢啦，直接揾 P value 啦。另外一個就係話你揾翻5%係幾多先？咁1.753啊嘛。咁即係話2一定細過5%㗎，係咪？因為呢個係繼續行㗎嘛，零喺中間點1.753，再過去到2呢個細過5%㗎嘛。
即係佢要如果 within 0去到1.753就唔使 reject 啦。
係啦，唔使 reject。
OK 好。
但係個 idea 都係一樣，即係話佢呢個2即係話大過1.753，即係話呢個位係細過5㗎嘛。即係呢個細過5㗎嘛。即係問緊呢個定呢個？咁你如果呢個喺度嘅，咁即係 infer 咗呢嚿嘢咯。即係話你暗示咗呢個係啱嘅。
好，唔該。
OK。